Okay, normal distribution curve. Also, first of all, let me tell you, it's also called Gaussian distribution. So you can let me write down, if you Gaussian distribution, right? So you should not be confused when this term appears sometimes. uh, I have already explained that in the middle there's mean, mode, median. Okay, it's a bell-shaped curve divided into two parts. So when we say divided into two parts, we know that this is 50%, and we know that this is also 50%, and this entire area is divided, I mean, the measurement is a standard deviation. What is this measurement, by the way? Like, for example, I can say my university is far away from my home, let's say 3 kilometers. So kilometers is my measurement through which I measure the distance. But here in normal distribution curve, okay, the measurement is standard deviation, that how many standard deviations you are far away from the mean. That I will also cover in Z score. Okay, my next video is going to be about Z score, and I will discuss in detail about there are three standard deviations which covers or which entirely the distribution covers one. Today, very quickly, let me do some questions so that it would be more clear. Okay, guys. So let's say that mean is 50, right? Mean is 50, and standard deviation sigma, we call standard deviation, is approximately. But by the way, guys, this is, as you know, that this is the population sigma, the population SD, and this is the sample mean. Okay, so you should keep in your mind that it means I'm actually referring to the population mean, okay, to the mu, which we call, okay. But again, when we solve the queries, we tend to forget that this is the population or this is the sample. But you should keep in your minds that we are talking about, because there is not much difference actually. But when it comes to the application, the real application, the real life application, sample mean and population mean are two altogether different things. Okay, but here in this area, because we are assuming that it is our sample, or assuming that it is our population, we can write either mean or mu. It really does not matter, because the formula remains the same. However, both concepts are very important and very, very different from each other. Okay, I have explained in my very first video, you can watch there. Now, let's say that our mean is 50, and our standard deviation is, I'm assuming it is let's say 5, right? My standard deviation is 5. So what does it mean actually? Standard deviation is 5. It simply means that I have already explained that within one standard deviation, the area is 68% within one standard deviation, right? So let's say the one standard deviation means 50 minus 5 is equal to 45. 50 plus 5 is equal to 55. So it means that my area, let me change the color in order to make some difference. Like, if this area, if I say that how much it is, so the total area in this question is actually 45 to 50, 55, sorry, not 50, 55. Okay, this is one standard deviation, because my mean, I am assuming my mean is 50. Here is my mean, and here is my first standard deviation. Likewise, if I say my standard deviation, what about the two standard deviation? How far from the mean? So we can say the same question, but SD is going to be 2 multiplied by 5, because 2 times, so it is going to be 10. And then let's do this way. This is going to be 10 for 50 minus 10, 40, 50 plus 10, 60. Okay, so now the area is 40 to 60. Okay, 40 is my variable, 50 is my mean, 60 is again my variable. Okay, how is it possible that plus 2 and minus 2? I have already explained in previous video. How about, let's say, how about 3 standard deviation? So very simple. 3 means 3 multiplied by 5. 3 standard deviations is going to be 15. So let me just uh, to have some space. Okay, here if I say 3, so it means that 3 multiplied by 5, okay, which is 15. So the area is going to be how much? Actually 40 minus 15, 35. 40, no, sorry, 50 minus 15, 15 is 35, and 50 plus 15 is how much? I think 65. So area is 13, 35, between 35 to 65. If I think the calculations are correct. 50 plus 60 plus, yeah, that's okay. You get my point. So this is how we actually learn how far we are from the mean. However, we can also calculate probability, or we can measure the distance, through or with the help of z score as well. Z score that we will be learning in our next class. Okay, there is one more question I have actually already written in order to save our time. Look at the question on the screen. The distribution of weights of for an American is approximately normally distributed, okay, with mean of 80 kg and standard deviation 5 kg. So normal weight of an American is 80 kilograms, and with standard deviation 5 standard deviation, which means that on an average, how far an American is from the average American weight, Okay, for example, let's say I collect a sample and the average is 80 kilogram, okay, but there are X, Y, Z, people. So I want to know exactly that how Y is far away from the 80 kilograms, the 80 weight, which is the average weight. Likewise, I want to know Z, how far he is actually from the average, which is because total is X, Y, Z, total is 80 kilogram, okay. Now, my first question is, what percentage of Americans weigh more than 90 kg? I just want to know randomly that those who are 90%, have 90 kilograms weight, what would be the percentage? And I take a sample. Let's say I take 100 people. I collect a sample of 100 people, okay, and then I want to know on an average, those who have 90 kilograms, more than 90 kilograms, what is the percentage of them? So what we have to do, let's say, again, I'm gonna let me draw the curve. So this is how we're gonna do. This should be straight line actually. Okay, so this is my average, which is my mean. My mean is 80. In the question it is already 80, so this is here 80. Okay, and I want to know 90. So first of all, and standard deviation is 5. Yeah, 5. So one standard deviation is 85, you know that. Second standard deviation is 90. So 90, yeah. And so because this is 1, this is 2, and this is in plus, because 90 is greater than 80, so it will move towards the right side, right? And I want to know this area actually more than 90%, okay, more than 90%. So we know already that the entire area is 50%, and this area is 34%, this area is 13.5% according to the empirical rule, okay, of probability distribution. So how much this area is left? So this is basically 2.35, because the entire area is actually 1, but the area that gets covered in normal distribution is 99.7%. 0.3 is still, not we kind of relaxation, because as I said in my previous video about the shoe example, that sometimes some fat people come, and there is a probability that there are some exceptions which cannot be covered under this normal distribution, and these are far, or these are the rare things or exceptions. Okay, so 2.35. So our answer is 2.35% actually. Let me just not 5, 2.35% actually people who are, whose weight actually more than 90% or 90 kg, sorry. Okay, let's see what's about the second question. The second question is, Now, the middle 95% of the Americans weigh between dash and dash. So 95%. So 95% means, as we know that from this chart we can see that 95 means the total, and between standard deviation minus 2 to plus 2 is actually how much? 95%. So but with two standard deviation. So here if we say with two standard deviation, if I draw a chart with two standard deviation, it simply means that this is my mean, okay, 80. With one standard deviation, it is 75, and here it is 85, minus 5 and plus 5, okay. And number 2 is 70, and here it is 90, right or not? This is standard deviation minus 2, this is standard deviation plus 2. So 75, 70, 85, 90. So my answer is actually between 70 to 90. Right, you get my point, because two standard deviation, we know already through the empirical rule, the entire area of 95% is between two standard deviations minus plus, right or not? What standard deviation is, guys? Very important. I have a very approximately 35 to 38 minutes lecture on standard deviation. I have described everything about standard deviation, how does it work, the practical implication, the real life use, how the formula is formed. Please go and watch the video number 2 or 3. You can search on my playlist. There is please go and watch that. Okay, I have also uploaded the syllabus, so please follow the syllabus as well. You can find on my YouTube main page, but you have to access from your desktop, not mobile phone. Okay, now let's see what is the question number 3. That how much time is left, because this video should not be very long. Okay, what percentage of Americans weigh less than 70 kg? Now we were talking about 90 more in between, and now less than 70. I just want to know from my 100 item sample, I mean the people sample, that what percentage of Americans weigh less than 70 kg? Those who have less than 70 kg. Okay, I want to know. So again, I'm going to draw this chart. 70, we know that here it is 75, we know that so it means that less than 70 means here. Again, the same thing. Okay, if we talk about less than 70, this is going to be again, we would say that how much it is according to the empirical rule. This is 34%, this is 30.55%, and my third answer is again 2.35%. But the difference is, this is about this and this is about the left. Actually, let me just color this. Is so there's a difference actually in both. So don't get confused, both are two different things. Okay, we will be discussing this in detail in hypothesis testing, left-tailed and right-tailed. Okay, now my next question is, what is my next question? Approximately 50% of Americans weigh more than 50% of Americans. So we know already that when we talk about 50%, it means that we are talking about this. Yeah, that we are actually talking about this, right? So more than 50%. So we know that more than 50% means what? We can simply put here that this is my mean, which is actually 50%, because mean, mode, median are equal at this point, and that is why it is called unimodal and symmetrical. Both sides are equal in shape, in size. Okay, I think you can give me this answer. Maybe you write in the comment section. Okay, because this is so simple, already, right or not? So I leave it to you. Let me just do the last question. What percentage of American weigh between 70 and 90? Although it's very simple, but let me just do it for you. Okay, but the fourth one you have to reply. So here is the mean, again 80, and it's asking that between 70 and 90. So here is 75 SD1, SD2 is actually 70 SD2, and here it is 85 SD1, SD2 is 90. Okay, so what is they are asking? They are asking that between 70 and 90, what percentage? So it means between SD minus 2 to plus 2, and we know our empirical rule that it is actually 95%. You can see here, actually within 2 standard deviation, it is actually 95%. Yeah, so we can say with the help of this chart, normal distribution curve, that my fifth answer is actually 95%. Okay, if you have any problem, you can still write to me. But this is not the end of normal distribution curve. There are so many things coming like z-score and hypothesis testing, t-test, z-test, canova test, and so many other tests, are coming, chi-square. So keep watching, because lecture series is going to be very, very simple, and I will be picking some more questions. There should not be any point left to get covered. Okay, so see you in my next video. Thank you so much. Bye bye. Take care.